Hello, everyone. Today we are working through agentic AI use case, more specifically focusing legal and financial contracts. This presentation was mainly made out of two papers. I think that these are all papers from JP Morgan AI research. The first paper is the law. It's a major paper we will focus on. It is describe about legal agentic workflows for custody and fund services contracts. The second paper, this one I think is published before law. FlowMind, it also proposed a way to automate the workflow generations with LLM. And law uses the FlowMind in the automatic workflow generation for custody contracts. Before looking into the solution, so let's first look at the use cases. Because as I don't have any legal or financial background. So I think it will be important to understand what kind of data we are going to processing with AI. So this use case mainly focus on custody and fund service contract. It is agreement between the client. The client can be a trust of funds, right, which has lots of money to manage, and then the custodian is a bank, right, who provide the services to the trust of funds. So usually in this agreement, you will have, specifically describe who is the client, the attention, address, telephone number, etc. Right? Describe the client, and also you have the custodian. So this is a State Street Bank and trust company who is going to help hold the um, assets for the client. Okay. And then this will be the custody contract agreement looks like. So yeah, so usually it's like any legal contract document. Well, it describes clearly about what this agreement is about, right? And in all the legal jargons that I definitely like don't understand if I don't have a legal background. But anyway, so this will, and also usually it has like a multiple sections, right? About briefly described about the definitions, appointment, and it needs to lay out all the details about the safekeeping securities and all the duties and the responsibilities of both ends. So this can be the original agreement or the master agreement that was drafted in the beginning. And then once that this agreement was signed by two sides, if there's any changes to this agreement, they can also sign a different contract called amendment. So the contract can also be amendment to a previous contract, right? So you have a amendment to the custodian agreement. And then this, well, mainly describes about, again, between the client and custody, about what is for example, the date is changed, what date extended, or you may want to add some additional responsibilities or that you want to, or executions you want to add to the original contract. Cool. So this is what the data looks like. So basically, as you can tell, it's agreement, right? Agreement document between the client and custodian. And it can be original first sign-off agreement. It can also be an amendment to the original agreement. This is the document we are going to process. And then what are the use cases? What are the tasks that we want AI to complete for us? So the use cases mainly include querying the contracts, right? It can be many different types of queries you can make to the contract database. For example, it can be a direct extraction, right? You can just do a simple Q&A against the contracts about the effective date and or the master date of the contract. It may also involve some reasoning there. For example, the contract talk about the effective date. And it may or may not mention about the termination date, but it mentioned the duration, right? And then from the initial date and duration, you may calculate the termination date. So the user may ask, oh, what is the termination date of the contract? And then this agent should able to reason about the query and able to do, say, the simple math to return the correct termination date for the contract. It can also be analytical task, right? Such as, for example, summarize the clauses or compare like multiple clauses across multiple contracts or different time periods. So a clause, so this is like a clause in a contract is usually a specific section that address a particular aspect of the agreement or law. So you can think of the clause as the modular information in the contract, right? And the clause can be, I think I will also list, yeah, okay, I haven't listed here, but we will see what is the list of common clauses in the contract. Yeah, so these are like three different categories of queries that this law agent is trying to cover. Here are some query examples, like what question you want to send to the agent. Right? For example, you want to say, okay, just find me all the termination dates of all the contracts from this custodian bank. Right? You can also say, okay, what is the master dates of the contracts between this client and this custodian? And say the fees and expenses may change over time, right? Across all the contracts. And then you may want to compare the fees and expenses clause. So this can be like a one important segment clause or paragraph or section in the contract. So you ask the agent to help you compare how the fees and expenses change over time. So as you can tell, there are some complexity in the legal domain and finance domain. I think it's a cross between legal and finance. So usually the legal documents is a lengthy, unstructured text document, right? It's usually very long, and sometimes the structure is not very well formed and may lack some explicit section declarations that you may need some reasonings and domain knowledge to figure out the sections. And when the paper was published in 2024 last year. So they also face a limited LLM context window. It's like a limited context window, how many text tokens you can pass to the LLM. Due to the legal document can be very long and may exceed the context limits of the general LLM. But I think recently with the latest released LLM, right, the Cloud for Sonnet, and also the open AI side, I think all the LM right now, kind of the upper limit is about 1 million token context window. So I think the context limitation may be less of a problem right now. But if you want to say optimize for the cost, right, because usually below 200K, you will get a cheaper price in the query. So if you want to optimize for the cost, maybe you may still want to think about how you want to optimize the tokens sent to the LM. And also in the legal space, there are complex legal jargons. So yeah, so this is the document usually has a very dense and nuanced language of legal contracts, and it requires a domain knowledge and specialized understanding. And then the LM may lack the understanding of these concepts. The last, I think they mainly focus on the cost and scalability because they want to enclose this to also for example, the lawyers, the drafters, and also maybe just some general users, right? Just want to understand the contract more. So they want to have a cost-effective and scalable service to analyze a large volume of contracts. Okay. So these are the use case and domain complexity. I actually like look outside the paper and then look at what are the popular current legal LLMs and platforms. Especially in the era of agentic AI, I think right now it's more shifting, building toward the agentic AI platform for legal space. So if you look back in 2022, Harvey AI, which is the most popular legal platform right now, it was seeded almost like 2.5 years ago. And then in 2023, it's like a boom of all the AI legal assistant and platforms was born. So like CoCounsel, Clear and Jenny AI and also Lexus Nexus. Yeah. Yeah, Lexus Nexus. So it was originally it's actually a very big company. It was originally provide the information and an analytics platform to the legal professionals. And then they also released legal Gen AI assistant using the Lexus plus AI. So Lexus kind of the source of information, right? They have, and then plus AI to answer the user's requests. And then in 2024, there's also a law LM for the US legal system, like a fine-tuned custom LM for law space. And then if you look at the recent days in 2025, it's interesting to see that the Lexus Nexus is aligned with Harvey AI. So basically, they announced the strategic alliance to integrate the information, the source, and also the Harvey AI technologies within the Harvey platform and jointly develop the advanced legal workflows. And also the global legal firm started rolling out using Harvey AI, like a major law firm start integrating the Harvey AI into their domain-specific AI workflows. Yeah, so this is kind of the current landscape of the popular agentic AI workflows and platforms. I think the Harvey AI can be one of the top winners in this market. So if you look into the Harvey AI, right, I think you can just search Harvey AI and they display lots of use cases and you can even ask for a demo. So in the Harvey AI, they have this kind of different types of on platform that they have this different kinds of features, functionalities there. They provide assistant that you can ask questions, analyze the legal documents, and also you can, with those information, it can help you draft faster with the domain specific AI. They also provide, like as we mentioned, the data security, right? To securely store and organize the legal documents. They also provide a way for you to research, kind of like a deep research, to look into this complex legal and regulatory or tax related questions. You are also able to use their pre-built a legal workflows, or you can also build your own. I believe this workflows is kind of like a drag and drop experience where you can like a non code person can use their platform to build this workflows tailored to different legal firms' needs. There's you can also do a lot of other add-ins or add-ons like the draft, edit, or review the contracts using this platform. And it's directly integrated in Word. So this is like they provide a builder so that you can just design your own legal workflows. Cool. This is their solution suite. So that's the landscape, and of course those are closed source services. If you look at the open source world, right, and then I look at the papers to see, oh, how whether there's any open published papers describing about how they built the agentic workflows, and then I find this law paper from last year from JP Morgan AI Research Lab. They are talking about this the shift from using the fine-tuned legal LM. Well, you usually need to do some instruction post fine-tuning, which can be expensive, which may require a lot more high quality labels, right? And it is also static because sometimes it's expensive to fine tune. So it's not very, you can frequently train the LM that much, right? So it's kind of like a static there. And then you may still need to do some prompt engineering because yeah, to catch up with the trends and changes, the prompts may not up to date there. So you need to continue to do the prompt engineering, and also due to the fine tuning, you lose the the general ability of the regional general LM. And then they propose to shift from the fine tune LM to directly use the general LM. And yeah, but one issue with the general LLM is again like how we can relate the general LLM to the domain knowledge in the legal space, right? So they propose to build this workflows using the specific like legal specific tools to help the general LLM reason about what tools to use, right? So that they get some in-domain knowledge and also in-domain tools so that they can complete the task better. And also these tools are cheap, reusable, and also very flexible. It's kind of like a MCP, right? So you can develop all kinds of tools, and so it's very extensible to add in new in-domain tools. And they also have some text agents. So this mainly leverage the LM reasoning capabilities about the summaries, while keeping the key informations, for example, the entity and date information in the summaries, and then do the clause comparison to see what has been changed over time in the contracts. And then they found that using this workflow, they are able to enable this interactive modification of the general LM. It's not like a weight modification, it's more like adaptation of the general LM, right, to the legal contract domain by with these additions of more tools and more specific agents. So law, so they mentioned about they ingesting the contracts. The contracts are mainly from ADGA. ADGAR it's a SEC database. So I believe if you drop such a contract, it needs to be submitted to SEC, right? The US SEC for the supervision and monitoring and also legal authority purpose. So they pull the contracts all from this authority database, and then they pull it on premise so that because I think the SEC database has some sorting limit, which may not be very efficient. So they just pull the data on to premise locally. And then they say like how they ingest these documents, and how long it spent to in terms of the sequential processing of these documents. And also they apply some AI metadata tagging. So as the question asks, right? So they process each document, for example, the common dates, right? The common entities, and also the sections, figure out how many sections does each document has, and thus make it searchable, right? So that you can index those sections and make them searchable. And then they talk about the tools. So that's the source. And then the second is the tools. There are mainly three types of tools, right? So there's the direct extraction tool, multi-hop reasoning, right? You can do simple math there. And then the text agents, which is going to do the summarization and comparison. So the direct instruction is basically like the contracts contain many different type of dates, right? Like the effective date, like when the current contract is effective, the master date, when its original contract was effective, the dated date, and the etc. So they can be many different types of dates in the contracts. And actually, they use a combination of a different custom approach to extract dates. like the Robert, a BERT model, the span detection. So span detection is mainly to detect the beginning and the ending point of a date. And then they can also do some HTML parsing or some regular expression heuristics to extract all the dates from the contracts. And also you may need to extract the parties, right? So the tool is to find and extract the associated parties, like who is the client, who is the custodian, right? Like who is the trust of funds, the customer, and who is the custodian bank. And on the multi-hop reasonings, so one major, like for example, one common task this is targeted is to calculate the contract life cycle. For example, we want to calculate the termination date of the contract's life cycle. So it's going to use the extraction first to extract the dates, and then it search for the duration or the termination date. If the contract only have the duration, then the tool needs to do some numerical translation and then add it to the initial effective date to generate a termination date. Right. So this type of task like needs to kind of plan some stats there and then do the execute and then execute the step by step to reach the final answer. There are also some multi-hop reasoning about retrieval of the master contract. First, we need to decide whether it is a master contract, like the initial contract, or it's an amendment contract, right? So the tools is going to classify and retrieve the master contract and based on the effective date, so that you know whether it is original or the master one or the amendment one, right? So based on the effective date. So if it determined to be an amendment to the master initial contract, then the tool is going to search for the master by matching the dates and parties, by matching the effective date and the client and custodians. There's also a document analyzer in the legal document is mainly the section how to classify each paragraphs into a proper clause, right, of the contract. So just to give an idea, like what this section is about. So this is a common sections or clause in the custody contract, right? Such as the contract section, authorized persons, governing law, termination, etc., etc. So these are the list of the key clauses you may commonly find in a fund custody contracts. So this step is they want to process each contract and then classify the paragraphs, right, into one of these section labels. So this section labels, so that you know each paragraph, like what is which section that this paragraph belongs to. They also, as an alternative, they also trained a separate model just for title generation instead of a classification task. In the end, they find the classification works better than generation. So as you can see, all the tools they develop here use some custom model or simple logics, right? To kind of like more fine-tuned versions of models to adapt to understand the legal concepts in the contracts. The last type is just a tax agent. So the tax agents is just like the prompt, right? You just choose a foundation model and then you draft up the prompts, more tailored to the task you want to complete, such as you want to generate summaries, that you want to provide a useful summary of the legal clauses, and again to write a good prompts for this, you need to have some domain knowledge to know what is a good summary of the legal contract. For example, you want to preserving the key items such as the entity names and dates, right? So this cannot be eliminated from the summary. Also, you want to write the prompts to compare different clauses in the contracts. So this is the comparison agent. So this agent, we're going to sort the sections from different contracts and then just compare the pairwise set of them one by one in the list. They also, because the documents can be very long, right? Like it could be out of the context window. So to handle a large bodies of text, they also do some chunking, right? They just repeatedly run the agents to each section or to a group of sections, and then condense the text into a manageable size, and then the summarized ones are then sent to the comparison agent, so that you kind of do conquer, divide and conquer, right? You first divide them into small chunks and then you pass the summarized information to the comparison agent. Okay, so these are all the tools they developed. So what I see is like to adapt to the legal domain or understand the domain knowledge better, they develop all these customized tools and prompts, right? So that the LM can understand the domain knowledge in the custody contracts. So this is a high-level overview of how they design the law in production. So the front end, user interaction, they use a Streamlit. Streamlit is an open source Python package to build the interactive app. Yeah, you can get answers, you can display the information to the users. And then from the front end, they are going to configure a user queries. So they also I will describe more details about this. And then they send the request to a code generation agent. So the key here is the code generation agent. This agent needs to understand, this agent automatically generate codes. So the codes, you can think of it as automatic workflow. So the code represents a workflow, right? It learns how to use all the tools, right? As we have just described, say the direct extraction, etc. And also the agents like comparison agent and summarize agents. So these are the coding generation agent is the key here to automate the workflow generation based on the user query. And of course, like when you run this, you may get some static or dynamic feedbacks on the code error, and then you send these errors back to the code agent, and hopefully they can fix these errors based on the error message they see. So there will be some reflections based on the errors of the code agent so that they can continuously refine the codes and make it executed successfully. And then all the documents they use AWS OpenSearch. So this is a distributed search and analytics cluster. You can connect it to a database, and you can run the index on those data, and then make it quick to search. And also this index will be kind of useful to rack type of applications, right? So this is the modularity of the document they focus on is the sections or clause, right, in each contract. You may also see here there's some pre-processing step where they want to lower the cost and speed up. They do some pre-calculations of the key dates, entities, information, and then store them in cache so that they don't have to recalculate this again and over again. And this cache can be also used in the retrieval task. And once this code is completed successfully, and then you see the results is going to send back to Streamlit to display to the users. Yeah, so this is a overall production infrastructure. And if you look at how they configure the user query, so they compose it mainly within two parts, because the user can send in any type of text, right? So they want to make it more standardized user queries. For example, they want to figure out what is the entities of the interest, who are the client, who are the custodian, and then they want to figure out what are the tasks to be executed, right? The task can be just is for all the contracts or find the masters or compare the clauses. And then this caching availability here is to reduce the runtime latency so that they can batch pre-processing the contracts beforehand and store them. And this includes features related to the parties and dates, because these are very common features that are needed by all the contracts. And usually the user queries will also mention which entity it is, right? So that they can directly retrieve from here. The section search. So this, of course, right, the legal text is like over 20 gigabytes and growing. You cannot store in cache. So, and also they want to retrieve the contract clauses or sections. So all these contracts are segmented into clauses and then indexed in the OpenSearch data store. And then for each contract, they say if there's any questions asked, they are going to retrieve the top 20 most relevant clauses or sections. I see the key part in this workflow generation is the code agent. So the code agent is responsible to mimic the planning part, right? So you have a task, and then the coding agent, which is also a LLM prompt, which I will show later, to figure out what are the steps you need to take to complete that task. Like it will involve some thinking, it involves breaking the questions into steps. And then each steps you can invoke a tool to complete that task. So this framework they mentioned is using the FlowMind framework, and so this is a chart from FlowMind, which mentions that like in agentic AI workflow, it can be drafted by domain experts, right? So it's a more prefixed workflow. And then what Airflow is trying to tackle is they want to be a AI generated workflow. And this AI generated workflow, it can be represented by codes. So that's why it's like a code agent, right? It can automatically analyze the query and then break them into steps and then write, for example, write Python codes to call the corresponding tools to complete the task. So if you are wondering what what the coding agent looks like, so these are simple illustration. So basically the prompt you send to the LM contains three parts. One is you need to set up the context. Usually the context is set up like you are who, right? So you may start with the role definitions and what is the job responsibilities, and then you need to tell what are the tools available to the coding agent to call. For example, these are all the functions, what are the inputs, and what are the return formats. And then you provide some instruction, right? So you instruct it to write modularized Python codes and using these functions to respond. Okay, so this is a briefer version of what is the code prompt look like. And yeah. So the code generation agent, so the prompt usually includes the tool names, the description of the tools. You may also want to provide some examples with the chain of thoughts, and you should also include some self-refinement prompt, say given some error, right? So if you are prompt with some errors, for the previous version of codes, you need to self-refine the codes there. So this is a kind of autonomous coding agents. And then the LM, and then these agents also needs to do some self-verification and validation of the code, such as the syntax validation, hallucination detection. For example, it calls some tools that doesn't exist. So you want to make sure that the code is calling the tools or functions actually exist in the toolkit. And also there'll be some runtime validation in case some error shows up, and then the agents can self-refine the codes. Okay, so this is the code agents. And this is an example the paper put. For example, like the user query is to compare the authorized person clause for this. for this fund. And then you may also want to provide some customized suffix added to the prompts that you just want to compare the five sampled non-empty contract sections, right? And then the coding agent takes the queries and the prompts, like the general coding prompts for this suffix, and then they are going to generate this codes there. So you can see also with some comments like step one, step two, step three, step four. So basically they are doing to get the agreement for this entity. They like extract the clauses and then yeah, do some error check if any clauses are were find, and then they just follow this instruction to for just compare five sample, right? Just for five. And then they compare the selected clauses and then going to return the comparison. So all these functions here are predefined tool, right? It can be a custom model or it can also be a customized prompt to the LM. I think the general summary or inspiration to me is for me, for example, right, to adapt a general LLM to a specific domain. I would think about first the sources, right? So what is the source of can be a document, can be images that I want to process, and how I want to pre-process and store them or index them for kind of retrieval type of task. And then I may think about what are the list of tasks I want to support. It could be a very commonly used functions. It can be a simple Python functions or prompts. If that task requires some reasoning, then it's still a LM call, right? And then to automate the workflow generation, I may think about like using this coding generation agent to help automate putting up a solution for the user queries. I think the key part of whether this should work is the coding agent. I guess the majority errors will also come from the coding agent that the code may not work, right? So you need also to have a robust framework for it to continuously refine and optimize itself so that it can be executed successfully. I think this framework should apply to I would guess like a majority of the simpler workflows there to help answer the any type of user queries in any domain. Some of the performance that they are reporting, but I don't think they choose a very strong baseline. I don't know why though. So yeah, so law, so this is their performance. So you can think of this hit rate or F1 as accuracy there. For example, you want to explore the contracts belonging to certain entities. You want to find the master agreements, seek the termination date, identify the parties, summarize and compare the clauses. You can treat these numbers as accuracy. And the baseline, I think they just use yeah, GPT 3.5 Turbo. So yeah, so I don't find this baseline very uh, strongest baseline, for me, I would choose a strong reasoning model. I will be interested to see with the customized tools, right? The tools that are related to this legal domain, how that is going to help, how that is going to improve the performance over a strong general reasoner model. I think that will be a very interesting data point to see. But anyway, in their paper, they just compare to 3.5 Turbo. Maybe at that time, the strongest reasoner model was not out yet. And then they're able to show that the agentic workflow is able to improve over the general baseline by a lot. One interesting thing is they also find the main source of error uh, in this task is the hallucination still. So for example, if some the model tends to always give you some date, even if that date doesn't exist. I think this is common. I also see it when I use it for my work, that the LM still tends to, if the data exists, it may accurately extract it. The problem is if the data doesn't exist, it may still give you an answer. So basically, the LM always trying to be helpful, even if that response is not what you want. So I think the it will be also interesting whenever you build agentic AI workflow or application, you may want to deep dive into the errors to see what type of outputs can be trusted. Also, if there's a way to trust it. Okay, so that's the main conclusions for law. So this, I think the law provides a framework to automatically build any agentic AI workflows and how to adapt a general LLM to specific domain, right? So the key idea is to build the reusable domain-specific tools and text and specific prompts or text agents. So and then use these tools to interact with yeah, so in this domain is the complex legal contracts. And also it is also when putting it into production, you may also want to think about how to optimize the cost, right? And provide it as an alternative to like existing expensive general fine-tuned legal LLMs. And also this framework with agentic AI is also very easy to update and extend with the new capabilities and tools. So the goal of this work is to streamline the workflow for both legal experts and also layer users who want to ask anything to the legal contract database. So it helps the users to improve the efficiency and accuracy in understanding the complex legal documents. I think this type of tool will be especially useful for me who are not coming from the legal domain. But if I ask the assistant in a plain English, it may help me, translate it into a precise queries to the system so I can get the correct answer from that.